Okay, I have a block of ice that weighs 100 grams and I'm going to add some energy to it. And I want to know what is the final temperature. Now, as I add energy to the ice, different things can happen, okay? Initially, the ice is going to melt, okay? So the heat added to the ice would be equal to the number of moles times the enthalpy of fusion, okay? Now, if I added enough energy to melt the 100 gram of water, and I still have excess energy, I can take that melted water and raise its temperature. So now the heat is equal to the mass times the specific heat capacity times the temperature change. And since I'm raising the liquid water, I will use the specific heat capacity of liquid water. Now, if I've added enough energy to raise it to 100 degrees, I could boil the water. Now that would be equal to Q is equal to the number of moles of water times the enthalpy of vaporization. That is, I melted it at 0. That took energy. Then I raised its temperature to 100. That took energy. Then I boiled it. That took energy. And notice it takes a lot more energy to boil it, 40 kilojoules per mole compared to melting it at 6 kilojoules per mole. And if I added that a whole bunch of energy, I can raise the temperature of the steam and have a superheated steam. Q equals mc of the steam delta T. Okay? So the question we got to ask is 30 kilojoules enough to melt the ice? Is it enough to melt and raise the temperature of the water? Is it enough to melt, raise the temperature of water, and boil it? Is it enough to melt, raise the temperature, boil, and raise the temperature of the superheated steam, okay? So the first thing I need to do is find out how much energy it takes to melt it, okay? So I take my 100 grams, and I know that it takes, each gram of water is 18 grams per mole of H2O. And I know that the enthalpy of fusion is 6.02 kilojoules per mole. So my moles of H2O cancel, my grams cancel, and I have my the kilojoules required to melt it, and I see that this is equal to 33.4 kilojoules. Now, I'm only adding 30 kilojoules, so I'm still going to have some ice left, okay? Most of my ice has melted, but the final temperature is 0 degrees C, because I haven't even added enough energy to melt it. And it takes more than 30 kilojoules to melt 100 grams of water. Thank you. Okay.